Look around you. What do you see? A phone, a chair, the clothes you are wearing, the window you gaze through? Everything is made of something. Everything is stuff. This stuff, these materials are not just passive objects in our world, they are active participants in our story. They are the silent partners in our journey as a species. The history of humanity is, in many ways, the history of our relationship with materials. We did not just find them, we learned to understand them, to shape them, and in doing so, they shaped us in return. This intimate dance between humans and materials is the very engine of civilization. We often define great ages of human history by the materials that dominated them. We speak of the Stone Age, the Bronze Age, and the Iron Age. This is no accident. Each new material we mastered unlocked a new level of possibility for our ancestors. It changed how they hunted, how they farmed, how they built their homes, and how they fought their wars. A better material meant a better tool, a stronger shelter, or a more powerful weapon. It was the key that opened doors to new ways of living, new social structures, and new ideas. The story of our progress is etched into the very fabric of the materials we have bent to our will. This journey of discovery is the heart of a field we now call materials science. It is the study of stuff, what it is made of, how it behaves, and how we can make it better. It is a discipline that blends chemistry, physics, and engineering to create the world we live in. Every great leap forward, from the first clay pot to the latest quantum computer, was underpinned by a breakthrough in materials. Think about it. Without the discovery of how to smelt ore, there would be no cities as we know them. Without the invention of glass, our view of the world, both literally and scientifically, would be far more limited. Understanding materials is about understanding potential. It is about seeing a lump of dull rock and imagining a sharp blade. It is about looking at a bucket of sand and envisioning a microchip that can connect the entire globe. This is the magic of material science. It gives us the power to transform the mundane into the magnificent, to take the raw ingredients of our planet and cook up a new future. As we stand here today on the cusp of even more profound discoveries, this field has never been more important. It holds the solutions to our greatest challenges and the blueprints for our wildest dreams. For millions of years, our story began with stone. The Stone Age was defined by what we could chip, grind, and shape from the rocks around us. Flint, obsidian, and chert became our first technological partners. With a piece of flint, we could create a sharp edge capable of butchering an animal or carving wood. This was a monumental leap. It gave our ancestors a power they never had before, allowing them to access new food sources and create more sophisticated tools. The simple act of striking one stone against another was the dawn of engineering, the first deliberate manipulation of a material to serve a human purpose. Our very brains evolved alongside this process, growing in complexity as our hands grew more skilled. This long era of stone tools, lasting for over 99% of human history, laid the foundation for everything that followed. We learned the properties of different stones, which ones were brittle, which were tough, and which held the sharpest edge. We developed techniques, passed down through generations for crafting axes, spear points, and scrapers. These were not just functional objects, they were expressions of ingenuity and the first stirrings of design. With these simple tools, we built shelters, made clothing, and created the first art on cave walls. The Stone Age was slow, but it was the essential training ground where we first learned the fundamental lesson. Mastering a material means mastering your world. Then, something extraordinary happened around 3300 BCE. Someone, somewhere, discovered that by heating certain greenish rocks, a new shiny substance would ooze out, copper. And even more brilliantly, they found that mixing this copper with another metal, tin, created something far superior: bronze. The Bronze Age had begun, and it was a true revolution. Bronze was not just a better stone. It could be melted and cast into any shape imaginable. A sword, a helmet, a sickle, a delicate piece of jewelry. For the first time, we could create complex, durable objects on demand. This was a paradigm shift in manufacturing and design. The impact of bronze was immense and far-reaching. It created new trade routes as society sought out the rare copper and tin ores needed for its production. It led to the rise of specialized artisans, the smiths, who held the secret knowledge of metalworking. Armies equipped with bronze weapons and armor were far more powerful, leading to the growth of empires and the first large-scale conflicts. Cities grew larger, agriculture became more efficient with bronze tools, and art flourished. Bronze changed the very fabric of society, creating wealth, power, and inequality. It was a testament to how a single new material can reshape human destiny. Just as bronze had redefined the world, another material was waiting in the wings to usurp it. This material was iron. Unlike the copper and tin needed for bronze, iron ore was incredibly common, found almost everywhere on Earth. The challenge was that it required much higher temperatures to smelt, a difficult technological hurdle for ancient peoples. But around 1200 BCE, blacksmiths in the Near East finally cracked the code. They learned to build furnaces hot enough to coax the metal from its ore. The Iron Age had arrived, and it would bring technology to the masses in a way bronze never could. Iron was the great democratizer of materials. Because it was so abundant, it was cheaper and more accessible than bronze. Suddenly, a common farmer could afford an iron plow, allowing him to cultivate tougher soils and dramatically increase his crop yields. A simple soldier could be equipped with an iron sword, making armies larger and more formidable. The widespread availability of iron tools fueled a boom in construction and craftsmanship. It was a tougher, more resilient material that could be hammered and worked into shape, creating everything from nails and hinges to chains and chariot wheels. This was a revolution built not on rarity, but on abundance. For centuries, iron was the king of materials, but it had a flaw. It was brittle and prone to rust. The quest was on to improve it. The Romans made advances, but the true breakthrough came much, much later. The secret was to add a tiny, precise amount of carbon to the iron. This new alloy was called steel. Early forms of steel, like that used in Damascus blades, were legendary for their strength and sharpness, but they were difficult and expensive to produce. The material was an art form, its secrets held by a few master craftsmen. It would take an industrial revolution to unleash its full potential. That moment arrived in the 19th century with the invention of the Bessemer process. This new technique made it possible to mass-produce high-quality steel cheaply and efficiently. The world was transformed almost overnight. Steel became the backbone of modernity. It was used to build towering skyscrapers, sprawling bridges, and thousands of miles of railways that connected continents. It created the engines, the machines, and the factories of the Industrial Revolution. Steel was stronger, more flexible, and more durable than iron. It was the material that literally built the modern world, a testament to our ever-growing ability to fine-tune a material to perfection. For thousands of years, our material progress was something you could see and touch. It was a stronger sword, a taller building, a faster train. But in the 20th century, the next great material revolution took place on a scale almost invisibly small. The material was silicon, a substance derived from one of the most common things on Earth's sand. On its own, silicon is not a particularly great conductor of electricity, nor is it a great insulator. It sits somewhere in the middle. It is a semiconductor. This seemingly boring property would turn out to be the key to unlocking a new technological age. Physicists and engineers discovered that by adding tiny, carefully controlled impurities to ultra-pure silicon, a process called doping, they could precisely control its electrical properties. They could turn it into a switch that could be flipped on or off with a tiny electrical signal. This was the invention of the transistor in 1947 at Bell Labs. The transistor was a solid-state device that could do the job of bulky, fragile, and power-hungry vacuum tubes. It was small, reliable, and efficient. It was the birth of modern electronics, the beginning of a journey that would shrink an entire room of computing equipment down to something that fits in your pocket. The true genius was figuring out how to put not just one, but millions and then billions of these tiny transistors onto a single small chip of silicon. This was the integrated circuit, or microchip. This invention propelled us into the information age. These tiny silicon hearts began to beat inside every piece of modern technology. They powered the computers that sent humanity to the moon. They drove the calculators that made complex math accessible to everyone. They were the brains behind the first video games, digital watches, and a host of consumer electronics that changed daily life forever. The world was becoming connected and digitized. all thanks to our mastery over this one humble element. Today, we live in a world built on silicon. Your smartphone, your laptop, the servers that run the internet, and the complex systems that manage our power grids and transportation systems all depend on it. This single material has created more wealth and transformed society more rapidly than perhaps any other in human history. It has connected billions of people and given us access to the sum of human knowledge at our fingertips. The story of silicon is a powerful reminder that the next world-changing material might not be the strongest or the shiniest, but one with a unique and subtle property that we can learn to control. As we move deeper into the 21st century, the boundaries of material science are expanding into realms that were once the stuff of science fiction. One of the most exciting frontiers is biomaterials. This is where we learn from nature, the greatest material scientist of all, and create materials that can work with, heal, or even become part of the human body. We are no longer just building things for people. We are building things for inside people. This field combines biology, chemistry, and medicine to solve some of our most personal and profound challenges. Think of the possibilities. We are developing artificial skin that can help burn victims heal, with sensors that can feel touch. We are 3D printing custom implants, like hip joints or skull plates, that are perfectly tailored to a patient's body. Scientists are creating biodegradable polymers that can act as scaffolding, encouraging our own cells to regrow damaged tissues or organs before safely dissolving away. We are designing drug delivery systems at the nanoscale, tiny particles that can target cancer cells directly, leaving healthy cells unharmed. These are not just materials, they are active partners in our health and well-being. At the same time, we are diving deep into the strange and wonderful world of quantum mechanics to engineer the next generation of materials. Quantum materials are substances whose remarkable electronic or magnetic properties arise from the bizarre rules that govern the universe at the subatomic level. These are not your everyday materials. They include superconductors, which can conduct electricity with zero resistance, and topological insulators, which conduct electricity only on their surface. Mastering these materials could lead to another technological revolution on par with the invention of the transistor. Imagine what we could do with them. Room temperature superconductors could lead to hyper-efficient power grids that lose no energy, ultra-powerful magnets for levitating trains, and next-generation medical imaging. Quantum computing, powered by these exotic materials, promises to solve problems that are currently impossible for even the most powerful supercomputers, revolutionizing drug discovery, financial modeling, and artificial intelligence. We are just at the beginning of this journey, learning to control the quantum weirdness of electrons to create materials with abilities we are only now starting to imagine. These are the building blocks of the future. We have journeyed from the first sharpened stone to the edge of the quantum realm. At every step, our progress as a species has been tied to our ability to understand and manipulate the stuff around us. Each material, stone, bronze, iron, steel, silicon, did more than just provide a new tool. It unlocked a new way of thinking, a new way of organizing our societies, and a new vision of what was possible. The story of materials is the story of human potential made real. It is a story of curiosity, ingenuity, and the relentless drive to make things better. This story is far from over. In fact, the next chapters might be the most exciting yet. We face enormous global challenges. Climate change, the need for clean energy, providing clean water and healthcare for a growing population. The solutions to these problems will not come from politics or economics alone. They will come from science and engineering. And at the heart of that effort will be materials science. We need new materials for better solar panels and more efficient batteries. We need new membranes for water purification. We need stronger, lighter materials for more sustainable transportation. This is where you come in. If you are curious about how the world works, if you like solving puzzles, if you enjoy taking things apart to see how they are made, then materials science could be for you. It is a field that sits at the intersection of everything, combining the fundamental wonder of physics and chemistry with the practical creativity of engineering. It is a field where you can work on the smallest of scales, arranging individual atoms to have the biggest of impacts on the world. You could be the one to discover the next silicon. So, the next time you pick up your phone or sit in a car or simply look at the world around you, take a moment to think about the stuff it is all made of. Think about the incredible journey of discovery that brought those materials into being. That journey is your inheritance. The tools and knowledge we have now are more powerful than ever before. The ability to design and create new materials from the atom up gives your generation a power that our ancestors could only dream of. The future is unwritten, and it will be built from the materials that you help to create. What will you build?